make that work. So yes, first question on the quiz, your theme song. I decided on a new one that I heard on the radio out of nowhere the other day. Running Down a Dream, Tom Petty. That's a very good opening music, so I'm looking forward to seeing what you guys had to write down. But on to more serious topics then. I'll go through the rest of these. I will read your answers. If there's anything specific that I want to say, I'll respond, but otherwise I gave you what I thought would be the right answer, and you're welcome to ask me any questions at any point about these. But the idea is just for you to give yourself a check on whether you're picking up the big picture of what's going on. These should be things you should be able to answer off the top of your head or pretty close to it. That's the idea. So in the latent trait models we will learn this semester, question 2. What characteristic of the data to be analyzed guides the choice of the model variant? For example, CFA versus IRT. The form of the response, yes. So it's not that one is better or worse or harder or easier, although some of them turned out to be harder because of the link functions in practice, but it's the form of the response. So we're starting with CFA because CFA is the same thing as regression. You're used to predicting continuous outcomes whose residuals are supposed to be normally distributed. For other kinds of outcomes, we need to add additional types of complexity to the model, but it's still the same idea that we have this latent trait that's a predictor that is responsible for why a person answered a set of questions the way they did. What are the 3 untested assumptions when using coefficient alpha to indicate a scale score's reliability? Unidimensionality, that's the big one. Tau equivalent, that all items are equally discriminating, all equally related to the latent trait. And last but not least, errors are uncorrelated, what's known as local independence. So it's kind of like unidimensionality, but a little bit stronger. What you'll find in the scales that you analyze is that some of them are going to be what I would call sufficiently unidimensional, meaning you might have to have 1 or 2 error correlations, but otherwise it's pretty much unidimensional. That's a more common result, and alpha doesn't have room for that. What we will see is that there are other ways of indicating reliability, such as coefficient omega, that still assumes unidimensionality because you can estimate it in the context of a factor model in which you've already demonstrated evidence for unidimensionality. But it builds into the formula differences in the discrimination, which is going to be a factor loading, as well as potential error covariances. So those are the things that you can relax because the coefficient will take into account the way the data actually are. And what are the only 2 things that matter when you calculate alpha? Sample size with respect to items. Yeah, not people, items. More items makes for a better alpha. And the other thing that goes into alpha, the average inter-item correlation. And note I specify average because it doesn't pay attention to the range of correlations, and that's why it can't indicate dimensionality. Very good. Oh yeah, I just did my last one. Why doesn't it indicate dimensionality? Who heard me what I just said?
It doesn't account for the spread of it.
Yeah, it doesn't account for the spread. So based on what we've just said, does it make sense, yes or no, to calculate alpha for a total score composed of multiple subscales? Nope. Do you see people do this? All the time. So yeah, there is no such thing as a total score alpha. It's based on unidimensionality. So if you have a need for subscales, that indicates that you likely have multidimensionality. So, all right, very good. Any questions or comments on that? No? Okay, then let me close that up. I believe everybody turned in their first homework assignment to get extra credit. Please? Thought maybe if I gave it a rest, it would come back. Because I'm going to start kicking it next, which is my other problem. I keep hitting source. If the source is correct, I'm just going to start hitting buttons. Play. Channel. Yeah. It's creepy, isn't it? What happens if I hit 1? Not available. 2? Not available. I thought it was 4. No. I don't know. Yeah, Brian, but I don't know where he is. But Becky sometimes is helpful. I don't know if she's in the office. Yeah, do you know where Becky's office is, Jihong? I introduced you guys across the hall. Can you see if she might happen to be there, if she might be able to help us out? Thank you very much. But in the meantime, we can talk about today's example, which is going with this idea of classical test theory, scale evaluation, the classical way. While we're waiting for him to come back, terms that we went over last time. So what are 2 item characteristics that will show up in all of the models to be learned? They both start with a D. Difficulty, and that is defined how in classical test theory? Sure, since you answered.
Like how difficult, or are you looking for mathematically, or just like what it is? I know it's determined backwards.
Yes. Item mean, yeah. So it's the mean. It's either the proportion passing, if it's a binary item, or just the score, the mean. And so you would think of an item that has more people getting it right as easier, but it would have a higher difficulty when difficulty is defined as the mean. So yes, it is backwards. Discrimination is the other one. I'll give you a hint. In classical test theory, how is that indicated? Feel free to look back at your notes if that's not off the top of your head. Yes, how correlated that single item is as a variable with the total, either including that item or sometimes excluding it, depending on what your software does. And on those, more is better. A stronger correlation indicates that the item is more related to the sum score, and the sum score is our best guess as to what someone's latent trait is, how to rank ordering them in terms of other people. So we will see those statistics in the example that I have for you today, as well as a few others. How to hack your alpha is one. And the example that I gave you is actually from, I'm sure some of you from special ed might recognize some of these last names. This is Beach Center work. What I did was a graduate student. I was a GRA working there in, dating myself, the early 2000s. And I helped them do some of the psychometric evaluation of 2 different scales. The child partnership scale, parent-professional partnership scale is this one, and also family quality of life. And I give you this example not because I think it's either the best or the worst case example, but it's just an example of the type of process that you go through and the type of information that you want to consider in thinking about which items to keep or remove from a scale. The nice thing about these sorts of analyses is that you can do them even if you have only 10 people. You can always stare at a correlation matrix. You can always compute alpha. You don't necessarily have to have huge sample sizes to do this kind of thing, because a lot of the problems that are going to show up when you do modeling are going to be foreshadowed by problems with descriptive statistics that you can get out of these alpha or correlation matrices. So I'm giving you examples in SPSS and Spss. I'm sure there are analogous ways of doing this in every other program because this stuff is fairly basic. But the first page here on example 3, I have 11 items that various exploratory factor analyses had deemed should go together. So we collected data in a new sample to see to what extent this was going to continue to hold together. And after this preliminary analysis, I did end up doing a confirmatory analysis, and the end result did have adequate model fit. So just as an aside here. So on the first page here, I added something new to this handout, which is my current favorite thing to do in Excel, the color map. Have you seen this before? See, this is where if I had a TV, I would demonstrate for you, but I can show you how it works. If you open up Excel somewhere on your computers, there is on the Home tab. Hello. I'm sorry? You're going to fix it for me? Please do. I'm doing laptop, and the TV just won't turn on once I hit the source. It says laptop like normal, and then it just goes to that blank screen. It's worked flawlessly for the past 3 weeks. Hello.
Hello. Hi. No, I was just trying to fix it. No, I don't know how to fix it either, so you can keep trying, but it's just not coming on.
Yep.
It's so slow.
It says laptop, and then it gets to the point where it normally says now playing, and I hit enter, and it just doesn't go.
I wonder if somebody did.
Let me make sure that my plug is all the way in, because that's something that could be too. No signal. We turn it off again, we turn it on again. See, this is the part where you can all check Facebook without me getting angry. Or email. Another benefit of being in a computer lab. What did you do? No, come back! This is, usually I hit enter. Yay! You did it. I don't know what you did, but you did it. Thank you so much. Thank you, team. Hooray. Oh, the tragedy of having to teach without a display. It's a good thing that I'm in this day and age. I don't think I could have handled it otherwise. So yeah, this is how I made these lovely things. As an example, I asked for correlations in SPSS. This is the SPSS output that I generated to do this. If you double-click inside the matrix, one of the options is that you can copy it, like that. And then you can paste it, I'll go down here, as such. You take the numbers that you want to highlight, and there's a tab here called Conditional Formatting. It's on the Home tab. And there are all sorts of choices, but the one I like is Color Scale. And it's a gradient of various colors. I tend to use this one or this one the most often. And that's how I made this. The other thing that I did to clean up this table is that I put a custom number format on here. So if you go up to number formats, there's more number formats at the bottom. And then there's a custom option that allows you to take off the leading 0, which in APA style you can do for any number that can't go above 1, such as a p-value. So I took off the leading 0 and made the table a little bit easier to read. So when you're doing initial sorts of descriptive analyses, I find this to be very helpful because large problems are going to jump out at you in a way that they never would if you were just staring at a giant table. So I tend to put the items that are supposed to go together next to each other so you can see the little pockets of green, and anything that is red is not good. So if,
Red is lower.
in this, the darkest red is the lowest, green is the highest in this case. So if we had any negatives, they would be the lowest. It colors it relative to the scale of whatever it's looking at. So if you just eyeball this, right, this is what I would call a qualitative analysis, but I'll probably get in trouble for saying that. If you eyeball that table, what item jumps out at you as being more red than the others? 14. Yep. Now the question is why? So these patterns are what alpha and the discrimination statistics and all that are picking up on. So before we get to that, I want to show you other pieces of the output here. So this is the reliability option within SPSS. First thing you want to note is it tells you how many people it kicked out for having incomplete data. Ruh-roh. So in contrast to the latent trait analyses, in which the model is going to be estimated with maximum likelihood, in which case you can have missing data to at least some extent, this doesn't allow it. So that can be problematic if you're analyzing test data in which items are deliberately different across people, such as the PPVT or some other kind of adaptive test where not everybody gets the same items. So this came up with a Cronbach's alpha of 0.9, which is pretty good, although there's 11 items, and so it's not hard. Now, one thing to keep in mind here, these item statistics, this is my item difficulty. These items range from a scale of 1 to 5. Do you see any potential problems here? Yeah, can you have an item with a mean of 4.8 and a standard deviation of 0.5 and have that go 2 standard deviations around the mean? Nope. So all of these items have ceiling effects to some degree. Even though they are 5-point scales, they're not going to be distributed normally. I can tell you that just from looking at the means. There's no way. So it is questionable whether or not a CFA model, which assumes these responses are normal, would be appropriate. And as it turns out, what I ended up doing in the publication is using the robust maximum likelihood estimator that had just come out in M+. Because of this non-normality, and because it had just come out, I actually screwed up my model comparison with it. And it's in print wrong. And a couple years later, somebody sent me an email and said, "Did you know you screwed this up?" I'm like, yeah, sorry. But I was a graduate student, and I tried my best. So yes. So the extent to which these items are going to be related with each other could be compromised by the fact that they have this strong skewness. So that's just something to keep in mind. They give you all kinds of stuff here that is of questionable utility. These first two tell you what the mean and the variance would be of the scale if the items are deleted. I'm not sure why one would need to know that. But the third column here is useful. This is my corrected item total correlation. So it's the correlation of each item with the scale sum minus that item, otherwise known as one of our D words. Discrimination, yeah. And if you take those R's and square them, you get the next column. So you can look at these and see the extent to which the items are correlated. Now, these ones are actually all pretty good. I don't see any that jump out as being uniquely terrible. The lowest one, you'll note, is number 14, which we already saw on the previous page, tended to be less correlated with the other items, relatively speaking. So this is what it's picking up on. The last column is how to hack your alpha. So this is a popular pastime for folks who are looking to trim scales and not compromise reliability. This tells you what your alpha would be if you got rid of that item. So our current alpha with all 11 is 0.91. This tells you what it would be if you got rid of the item. So any alphas that are higher than current indicate that that item is actually dragging it down. And most of these look like they're relatively okay. 14 is one that's a little bit high, and so is 5. So 14, if I were going to get rid of anything to simplify the scale, based on the data, indicates that it is less like the others. But based on the items, do you see something that makes 14 different than the others? And you don't have to be a special education researcher to play along here. I'm just asking you to read the words and tell me what looks different about 14 than the others. That's one, yeah. Are honest even when they have bad news. So you could be honest, dishonest all the time, or dishonest only sometimes. That's one thing. I'm going for something even more obvious. So this is the scale that's supposed to measure how well the professional treats your child. This is the child subscale of this instrument.
How well someone else treats your own kid?
Yeah, how well the professional that you're working with, for your kid that has special needs, basically how important it is for each of these things, and then how satisfied. There's two different questions. This is important. Yes?
That's a question about, like, how the person is interacting with the parent.
Yeah, it doesn't have the word child in it. It's focusing on a different topic. And then you might ask yourself, well, then why did we put it in the child subscale? And the answer is because EFA told us to. There is no other reason than that. This is how it fell out in the previous data set with the previous analysis. And by that margin, you might look at some of the other ones for the same problem. Number 10, are available when you need them. That's about you, not the kid. Even though, by all indications, number 10 is not necessarily problematic relative to the others. It's problematic when you think about the items measuring one construct as cleanly as possible. So we decided to get rid of 14 and move it to the other scale, which is about how well the professional interacts with parents. Repeat the process. Did the same thing with 10 for the same reason, even though the statistics didn't necessarily support that decision. And we end up with 9 items that have a correlation, or an alpha of 0.9 instead of 0.91. And all of these items that are left have something to do with your child. Yes, sir? So we had items, yeah, I think I'm following you. Yeah, we had items that were measuring 2 related constructs. Basically, you have this, it's a partnership between you and the professional, and you can be happy or unhappy about how they treat you or how they treat your child. And so these were 2 different dimensions of activity that we wanted to measure. And all of these items had something to do with the child, except for 2, and the only reason that they're in this pool is because EFA put them there. When you look at it post-talk, you think, wait a minute, that doesn't make a lot of sense. So my point here is that this is both sort of stats and art. Number 14 was problematic for the content reason, but also because of its lack of correlation with other things. Number 10, it's just the content. So when you're building scales, you really do want to keep in mind what is the wording and can you make it more consistent, or does this item really just belong on a different subscale, even if EFA didn't put it there. So we ended up with this overall child subscale with 9 items that has basically the same level of reliability even after getting 2 off of it. And then we moved those 2, number 10 and 14, over to the family scale, which is how the professional treats you. So does anyone else in here use Spss besides me at this point? A few people? So here's a trick in Spss, by the way. I'll show you what I did to make that correlation table. I'm not sure how well you know this, but in ProcCore and Spss, there's an option called Out, and it will save the correlation matrix to a data set. The one that it prints in the output has the sample sizes and the p-values in the way. So if you run that analysis, there's your correlation matrix. You go over to your libraries, and in the work library, here's my correlation matrix that has all of the statistics that I don't want, but it's the correlations just in a nice, easy matrix form. If you right-click on that data set, there's an option called View in Excel. And there it is. So no more typing numbers, ever. So that's how I formatted that one. Okay. So now let's play the same game. Qualitative analysis of quantitative data. Tell me which one is broken. 20, right? Sticks out like a sore thumb when you look at it this way. So let's see what our items are for this one. So breaking the table across, or taking the table across 2 pages here. So all of these are about how the professional treats you, the parent, or you, the family, not how well they do their job in helping your child. So there's our friends from before. Number 10 are available when you need them. 14 are honest even when they have bad news. And 20, protect your family's privacy. So this is a point where the people who made the scale, I told them that I think 20 should go based on the stats, and they said, That's a really important aspect that none of the other items are tapping into. So we're keeping it for reasons of validity, not reasons of reliability. That was their call. I said, okay, that seems reasonable to me. It's not even one of the highest mean ones. It's right there in the middle. So it just seems to be slightly off from the others, but not in a way that's so bad that we can't keep it. Here are the rest of the statistics here. So correlation with the total, as well as the alpha if deleted. So alpha would go up to 0.92 if we got rid of 20, but that's not a huge enough jump for me to throw a fit about. Alpha is already 0.2. Instead, the direction that we decided to take this to simplify it is to avoid redundancy. So number 10, are available when you need them. That's a broader picture way of asking things like return your messages, keeps appointments, plans meetings at times that are convenient. Available and dependable sort of take in mind all of those specifics, and so that was the direction that we took it. For reasons that had nothing to do with alpha or low inter-item correlations, we decided to see if we could get rid of 19, and then 17 and 18 for the same reason. So there's this chunk there in the middle that we thought were overly specific and could be covered by available and dependable. And that's an admittedly subjective decision, but it worked out that we had 9 items in each of our subscales. The alpha was 0.88, and these things do hold together with decent reliability as unidimensional factors for each of them, with a correlation between the two. Yeah?
So then the motivation for taking them out is the next time you give the scale to someone else, it's shorter?
Yep, that was the idea, was to make it as short and non-redundant as possible, because parents are busy and they don't want to fill out lots of items. That was the thing. So no matter what you're planning on doing in terms of psychometric analyses, these sorts of activities, staring at a correlation matrix, checking your means, at the very least you'll see if someone miscoded your missing data, right? If the ranges of your variable goes down to -99, you know something went wrong. Don't laugh. That's actually, I've had people turn in assignments where they had a descriptives table where the minimum of something was -99, and I thought, So that's that. I'm not going to ask you to do any homework on these sorts of analyses because I'm guessing you're already familiar with them. And what we will learn in the next unit is how to actually test these assumptions that alpha is predicated on: unidimensionality, equal discrimination, and no error covariances. So, questions? All right, then I am shutting this one off, and I am pulling out the next lecture, number 4, that I just posted yesterday. All right, so I'm going to